Good morning, myself Maninder Kaur, lecturer chemistry. Today my topic is laws of electrolysis. Now what is electrochemistry? Electrochemistry is a branch of chemistry that studies chemical reactions which take place in a solution at the interface of an electron conductor, a metal or a semiconductor, and an ionic conductor, which involves electron transfer between electrode and electrolyte or species in solution. History of electricity. Thales of Miletus is credited with the discovery that amber, when rubbed with cloth or fur, acquired the property of attracting light objects. The word electricity comes from electron, the Greek word for amber. Michael Faraday in 1791 to 1867 began his career in 1813 as Davy's laboratory assistant. In 1834, Faraday developed two laws of electrochemistry. Now, first of all, we will discuss the first law of electrochemistry. The amount of a substance deposited on each electrode of an electrolytic cell is directly proportional to the amount of electricity passed. What is first law? The amount of a substance deposited on each electrode is directly proportional to the amount of electricity passed through the cell. Now, what is second law of electrochemistry? The quantities of different elements deposited by a given amount of electricity are in the ratio of their chemical equivalent weights. Second law, the quantities of different elements deposited, they are in the ratio of their chemical equivalent weights. Alessandro Volta's discovery in 1793 that electricity could be produced by placing two dissimilar metals on the opposite side of a moistened paper. The study of interchange of electrochemistry is the study of interchange of chemical and electrical energy. Chemical energy is converted to electrical and electrical to chemical energy. So, it is the study of interchange of chemical and electrical energy. Definitions of electrochemistry: a science studying the relationship between chemical energy and electrical energy and the rules of conversion of two energies. Another definition: electrochemistry is the study of solutions. It is the study of solutions of electrolytes and of phenomena occurring at electrodes immersed in these solutions. Few terms are used in electrochemistry. Ion. Ion is an atom or molecule in which total number of electrons is not equal to the total number of protons. Ion is an atom or molecule in which the total number of electrons is not equal to the total number of protons, giving it a net positive or negative electrical charge. The name was given by Michael Faraday for the substances that allow a current to pass or go between electrodes in a solution when an electric field is applied. Now, what are cations? Cations are elements with one or more positive charge, one or more positive charge when dissolved in soil water. Cations are elements having one or more positive charge when dissolved in water. For example, potassium K plus 1, sodium Na plus 1, calcium Ca plus 2, magnesium Mg plus 2, iron Fe plus 2 and aluminium Al plus 3. So, these all are cations. What are anions? Ions consist of either atoms or group of atoms that have a charge either negative or positive. If they have gained electrons, they will be negatively charged due to having more electrons than protons. They are called anions. Example: acetate, bromide Br-1, hydroxide, carbonate, chloride, cyanide, fluoride, nitride, nitrate, phosphate and oxide. So, these all are anions. Ionization, the process of splitting of an electrolyte into ion. The process of splitting up of an electrolyte into ion when dissolved in a solvent or in molten or infused state is called ionization. Electrical conductivity. Electrical conductance is an electrical phenomenon where a material contains movable particles with electric charge, such as electrons, which carry electricity. Metallic or electronic conductors, the conductors which transfer electric current by transfer of electrons without transfer of any matter are called electronic conductors. The conductors which transfer electric current by transfer of electrons without the transfer of any matter are called electronic conductors. Metals such as copper, silver, aluminium, etc. Non-metals like carbon, graphite, it is an allotropic form of carbon. Applications of electrochemistry. First is hydrometallurgy of metal. electrolytic preparation, electroplating and electrolytic oxidation. Second is batteries, primary batteries and secondary batteries. Third is electroanalysis, polarography, pH, electric conductivity. Introduction. By 1812, Swedish chemist Bergelius could propose that all atoms are electrified, hydrogen and metals being positive and non-metals negative. Michael Faraday to show that there is a direct relation between amount of electric charge passed through the solution and the quantity of electrolysis products. There is a direct relation between amount of electric charge passed through the solution and the quantity of electrolysis products. Chemical reactions where electrons are transferred between molecules are called oxidation reduction reactions or redox reactions. Electrochemistry deals with the situation where oxidation and reduction reactions are separated in a space or time connected by external electric circuit to understand each process. Electron transfer reactions. Electron transfer reactions are oxidation reduction or redox reactions. Results in the generation of an electric current or electricity or be caused by imposing an electric current. Therefore, this field of chemistry is called electrochemistry. Terminology for redox reactions. First is oxidation. What is oxidation? It is the loss of electron by species. Increase in oxidation number, increase in oxygen. Oxidation is the loss of electrons. Reduction. It is a gain of electron. Decrease in oxidation number, decrease in oxygen or increase in hydrogen. Reduction is the gain of electron or increase in hydrogen. Oxidizing agents, they are electron acceptors. So, this is oxidizing agent. Reducing agent, they are electron donor. This sodium, it is a electron donor, it is a reducing agent. There are three definitions of oxidation. First is the loss of electron. Second is the gain of electron. And third is the loss of hydrogen. Reduction. There are also three definitions for reduction. First is the gain of electron. Second, loss of oxygen. Third, gain of hydrogen. So, this is called reduction. Non-electrolytes. A non-electrolyte doesn't dissociate at all in solution and therefore does not produce any ion. What is non-electrolyte? It doesn't dissociate in solution and therefore doesn't produce any ion. Non-electrolytes are typically polar covalent substances that do dissolve in water as molecules instead of ions. For example, sugar, its formula is C12H22O11. It is a good example of non-electrolyte. Electrolytes are chemical compounds which conduct electricity either in fused or in aqueous solution state, which chemical decomposition due to the flow of current through it. So, electrolytes are the compounds which conduct electricity either in fused state or in aqueous solution. For example, acid solutions HCl, HNO3, alkaline solutions like KOH, sodium hydroxide, ionic salt solutions PBBr2 and copper sulfate. Strong electrolyte. What is the difference between strong electrolyte and weak electrolyte? Strong electrolytes, they allow a large amount of electricity to flow through them, and in case of weak electrolytes, they allow a small amount of electricity to flow through them. Strong electrolytes are completely dissociated. Weak electrolytes, they are partially dissociated. Strong electrolytes solutions contain only free mobile ions, but weak electrolytes, they are partially ionized and partially unionized molecules are present. Strong electrolytes, acids like HCl, HNO3, bases like sodium hydroxide and KOH, salts like CuCl2 and PBBr2. Weak electrolytes, acids like acetic acid and oxalic acid, bases like ammonium hydroxide NH4OH, and salts like sodium carbonate and sodium bicarbonate. Insulators, the materials which do not allow electricity to pass through them are called insulators. Electrolysis, it is the passage of direct electric current through an ionic substance. Electrolysis is the passage of direct electric current through an ionic substance that is either molten or dissolved in suitable solvent, resulting in chemical reactions at electrodes and separation of materials. 1800, William Nicholson and John Ritter decomposed water into hydrogen and oxygen. In 1807, potassium, sodium, barium, calcium and magnesium were discovered by Sir Humphrey Davy using electrolysis. In 1886, fluorine was discovered by Henry Moissan using electrolysis. And Hallroth's process developed for making aluminium in 1886. In 1890, Castor-Kellner process developed for making sodium hydroxide. Components for electrolysis. The main components required to achieve electrolysis are an electrolyte. It is a substance containing free ions which are the carriers of electric current in the electrolyte. If the ions are not mobile as in a solid salt, then electrolysis can't occur. Electrolyte is a substance having free ions which are the carrier of electric current in electrolyte. If the ions are not mobile, as in case of solid, then electrolysis can't occur. Electrodes. Electrodes allow the electric current to enter or leave the electrolytic solution. The electrodes, they allow the electric current to enter or to leave the electrolytic solution. They are 2 in number. They are connected to a battery and can be classified as cathode and anode. Two types of electrode, anode and cathode. Anode connected to the positive terminal of the battery, and cathode, it is connected to the negative terminal of the battery. Anode acquires positive charge during electrolysis and cathode acquires negative charge during electrolysis. Here the migration point for anions and it is the migration point for cations. Process of electrolysis. The key process of electrolysis is the interchange of atoms and ions by the removal or addition of electrons from the electric circuit. The required products of electrolysis are in some different physical state from the electrolyte and can be removed by some physical processes. Process of electrolysis. An electrical potential is applied across a pair of electrodes. Two electrodes, cathode and anode, immersed in electrolyte. Each electrode attracts ions that of opposite charge. Now, positive charged ions, that is cations, they move towards the cathode. Cations having positive charge, they move towards the cathode, but negatively charged ions like anions, they are also called anions, they move towards anode. At the electrode, the electrons are absorbed or released by atoms and ions. Those atoms that gain or lose electrons to become charged ions pass into the electrolyte. Those atoms that gain or lose the electrons, they become charged ions, pass into the electrolyte. Those ions that gain or lose electrons to become uncharged atom separate from the electrolyte. The formation of uncharged atom from ions is called discharging. Process of electrolysis. The energy required to cause the ion to migrate to the electrodes and the energy to cause the change in ionic state is provided by external source of electrical potential. Oxidation and reduction at electrode. Oxidation of ion or neutral molecules occur at anode. The reduction of ions, they occur at cathode. For example, it is possible to oxidize ferrous ion Fe plus 2 to ferric ion Fe plus 3 at anode. Another example, it is possible to reduce ferricyanide. This is the example of a formula of ferricyanide. Ferricyanide ion to ferrocyanide FeCN4, ferrocyanide. Faraday's laws of electrolysis. Faraday's laws of electrolysis are quantitative relationships based on the electrochemical researches published by Michael Faraday in 1834. Faraday's laws of electrolysis, the laws which govern the deposition of substances on electrodes during the process of electrolysis is called Faraday's laws of electrolysis. The laws which govern the deposition of substances in the form of ions on electrodes during the process of electrolysis is called Faraday's laws of electrolysis. These laws given by Michael Faraday in 1833. Michael Faraday, a British chemist, studied the decomposition of solutions of salts, acids and bases by electric current. Faraday's first law. Faraday's first law states that mass of any substance deposited or liberated at electrode, the mass of substance deposited is directly proportional to the quantity of electricity passed. That is, W is directly proportional to Q. W is the mass of substance deposited. Q is the quantity of electricity passed. W is mass of ion liberated in grams. Q is the quantity of electricity passed in coulombs. Now W is equal to IT. I is the current in amperes and T is the time in second. So W is directly proportional to I into T. Therefore, W is equal to Z I T, where Z is constant. This is also known as electrochemical equivalent of the ion deposited. Z is called electrochemical equivalent.